Traumatic brain injury is one of the leading causes of death in young adults. The reason for this is because scientists have still not discovered a way to effectively treat the second stage of traumatic brain injury. In the second stage, the capillaries within your brain burst, causing hemoglobin to be released. The hemoglobin then breaks down to form iron. The ions can then go and react with their surrounding cells and cause the formation of lipid and alkoxy radicals. These radicals can then go on to form neurotoxic aldehydes, which can have very devastating effects on your nervous system and cause potential death. Thus, Rice University has investigated PEG-ATCs as a potential nanovector to treat traumatic brain injury. They did some tests and found that they were very effective in treating traumatic brain injury, but did not know why. One of the researchers proposed that they were acting as chelators. A chelator is any substance that binds to a metal ion and prevents it from reacting with other substances. In order to test this, we ran an ascorbic acid assay. Ascorbic acid is nothing more than vitamin C, which you can see over here. And the reason we chose this molecule is because it is very prone to oxidation in the presence of iron. Next, I need to find out the absorbance peak of ascorbic acid. In order to do so, I ran a Weber mole calculation and found it to be approximately 180 nanometers. Now, in order to do the test, I wanted to see whether or not ascorbic acid would be oxidized when in the presence of iron and PEG-ATCs. I did this through using a UV spectrophotometer. As you can see here, at the time 0, which is the highest peak, it had a very large peak. However, over time, the ascorbic acid started to be oxidized and the peak started to decrease. However, this graph is just ascorbic acid and iron. However, whenever PEG-CC was added to the solution, there was no decrease in the peak. It was very minimal, almost barely noticeable. Thus, this can go to prove that ascorbic acid was not being oxidized and that the PEG-CCs were actually acting as chelators. From this, we can now probably assume that PEG-ATCs has chelation as one of the main factors as to why it is such a good treatment for traumatic brain injury.